Suppose you run an ice cream store. Right now, you're selling your ice cream cones for $2 a piece, and you're selling 20 cones a day. Should you try to improve your business by putting your ice cream cones on sale for $1 a piece? In order to answer this question, you'd need to know how your customers would respond to a change in your price. And this brings up the question of the elasticity of demand. Elasticity means responsiveness. Suppose you have a piece of elastic. If you stretch it, it responds and changes shape. If it didn't change shape, that is, if it were unresponsive to your pulling on it, it wouldn't be elastic, would it? Elasticity means the extent to which the quantity demanded changes when there's a change in the price of the good. We define elasticity as the percentage change in quantity demanded that results from a percentage change in the price of a good. Let's look at those ice cream stores now. Suppose Angie runs an ice cream store where she charges $2 a piece for her ice cream cones. And right now, she's selling 20 cones a day. If Angie puts her cones on sale at $1 a piece, she discovers that her customers want to buy more cones. That is, as the price falls, the quantity demanded increases. But they only want to buy 10 additional cones daily for a total of 30 cones per day at a price of $1 a piece. Angie's demand curve for ice cream cones looks something like this. Her customers want to buy a few extra cones when the price falls, but the demand curve is relatively steep. We'll label this D sub A for the demand on the part of Angie's customers. Across town, Barney has an ice cream store. Barney starts, like Angie did, with a price of $2 a piece for his ice cream cones. He's also selling 20 cones per day. Now, when Barney puts his cones on sale at $1 a piece, his customers get very excited and come in and buy 50 cones a day. That is, Barney's customers are much more responsive to a change in the price of cones than were Angie's customers. If we connect these two dots for Barney, we see that Barney's customers' demand curve is flatter. That is, for a given change in the price of ice cream, Barney's customers will buy many more additional cones than will Angie's customers. When the price goes from $2 to $1 at the two stands, Angie's customers respond a little, but Barney's customers respond a lot. We say that Barney's customers' demand for ice cream is more elastic than Angie's customers' demand for ice cream. Now, why should you care about this? See if you can answer this question. What happens to the total revenue that Angie raises when she changes the price of her ice cream cones from $2 a piece to $1 a piece? Does her total revenue increase or does it decrease?